So I'm going to do these three last questions from the 7.1 7.3 worksheet because these are the double conversions. They're a little more complex than the single ones. So here's a video that you can watch if you need to review how to do these. Okay, so the first question asks us to convert 0.043 kilograms of lead into ions. Ions are a type of particle. So we are going from mass here, which has been given to ions. Okay, so the answer will be ions of lead. Ions. So right now we have mass in kilograms. So the first thing we have to do is convert it into grams. So we're going to use this conversion factor right here where 1 kilogram is 1000 grams. So I'm going to put 1 kilogram on the bottom and then 1000 grams on the top. 1000 grams of lead. So that'll cancel out my kilograms and kilograms. Then once I have grams, I have to go to moles. And in order to go to moles, I'm going to need my molar mass from the periodic table. If you look under the symbol for lead, you'll see that it's 207.2, and that is the mass of 1 mole of lead. So I want to keep the unit of moles, so 1 mole of Pb on the top, and then 207 0.2 grams of lead on the bottom. That's the molar mass of lead. So grams of lead and grams of lead will then cancel out. Now I want to go to particles of lead, but the particle specifically is ions, so it's going to be 1 mole of lead is 6.02 times 10 to the 23rd ions of lead. So I want to cancel out the moles, so 1 mole of lead on the bottom, 6.02 times 10 to the 23rd ions of lead on the top. So if you take 0.043, you times it by 1000, then you divide it by 207.2, and then you multiply that answer by 6.02 times 10 to the 23rd, you should get 1.25 times 10 to the 23rd ions of lead. Okay, so that's the answer for number 9. Let's look at number 10. You have to convert 17.68 grams of Cl2 to molecules of Cl2. So you have been given mass, you have to go to moles, and then from moles you have to go to molecules of Cl2. Okay, so the first conversion is going to be based on the molar mass of chlorine. 1 mole of chlorine, remember diatomic chlorine means you have to take the molar mass of chlorine, which is 35.45, and times it by 2, so that should give you 70.90 grams of Cl2. So that's the first relationship that you're going to use in order to convert to moles. Okay, so grams have to cancel out, so 70.90 grams of Cl2 on the bottom, 1 mole of Cl2 on the top. Grams cancel out. Then we need to go to molecules, so 1 mole of Cl2 on the bottom, 6.02 times 10 to the 23rd molecules of Cl2 on the top. So let's plug it in. 17.68 divided by 70.90, and then we're going to times that by 6.02 times 10 to the 23rd. That gives me 1.50 times 10 to the 23rd molecules of chlorine. Okay, one way to check if you're doing this correctly is to see if your units cancel out. So in the previous problem, kilograms cancel out, grams cancel out, moles and moles cancel out, and you're left with the unit that you want. In this one, grams of Cl2 cancel out, moles of Cl2 cancel out, leaving you with molecules. If your units don't cancel out diagonally, then you've gone wrong somewhere. So go back and check to see. Maybe you flipped a conversion factor, which is the most common error people make. Okay, now the last one is asking us to convert 2.31 times 10 to the 24 formula units of CaClO4 to grams. So we have been given formula units, which is a type of particle, and we have to go to mass. So I should end with grams of CaClO4 2. So calcium perchlorate. Okay, so we have to go from formula units first to moles, and then from moles we can go to grams. Okay, so look at this compound. This is not a compound you can just directly find on the periodic table, right? Because these are not elements. This compound is made up of multiple elements, which we need means the first thing we need to do is find the molar mass of the compound, which we did in number 5 on this worksheet. Okay, you learned how to find the molar masses of compounds. So if you forgot how to do that, go look at number 5. So calcium, there's one of them in this compound, one calcium, and look, there are two chlorines, so 2 times Cl, and then there's 2 times 4, 8 oxygens. Okay, so calcium is 40.08 from your periodic table, grams per mole. Then 2 chlorines is 70.90 grams per mole because it's 35.45 times 2. Okay, and then 8 oxygens is going to be 16 grams per mole times 8. Actually, let me do that here as well. This is 35.45 grams per mole times 2. Okay, so this is 70.90 grams per mole, and this is 16 times 8 is 128 grams per mole, and then 40.08 is just there. 40.08, there's only one of them. So I'm going to now add these up. 128 plus 70.9 plus 40.08 is equal to 238.98 grams per mole. So that is the molar mass of calcium perchlorate. Okay, so another way to write this would be to write it as 1 mole of calcium perchlorate is equal to 238.98 grams of CaClO4 2. The reason I keep showing you how this grams per mole becomes this relationship is because I want you to remember that this thing is an abbreviation, and this is the fully opened form of that. Okay, so now we're ready. So we have formula units. I want to go to moles. So that is a type of particle. So 6.02 times 10 to the 23rd formula units of CaClO4 on the bottom. Okay, and 1 mole of CaClO4, 2 on the top, and then the next one is going to be using our molar mass here. So 1 mole of CaClO4 2 on the bottom, 238.98 grams of CaClO4 2 on the top. Formula units cancel out, moles cancel out. We know that our unit cancellation worked out nicely. So let's do the question now. 2.31 10 to the 24 divided by 6.02 times 10 to the 23rd times 238.98 gives us 917 0.01 grams of calcium perchlorate. Okay, so that's the 3 last questions which have double conversions on the 7.1, 7.3 worksheet. Okay.